Got our data type point. Although point is useful, it's probably not good for graphing, because if you were going to do a graph, you'd probably want floating points or real numbers in here, so 2.5 instead of just an integer. However, if we were using it for screen coordinates, which are always integers across the screen, then that would be fine. What I want to do is sort of extend this so that it deals with a particular data type which only ever uses integers, and that's a fraction. So a fraction has to have an integer as the numerator and has to have a fraction as the denominator. It can't have any real or floating point numbers in those places. So I'm going to create a fraction class. Now, fractions are a little bit different to points, because with a point it was straightforward. We could just set these x and y values, fetch them, or do something with them. However, with a fraction there are lots of rules. If I want to add a fraction, there's a rule to do that, or subtract. Same for multiply and divide. There's a lot of different rules that we can apply to a fraction, and we're going to see how we can handle those in one way, not the best way, but to get a handle on how to use Java, how to use data types, how to create your own data types, and how to set rules. So let's start off by creating a new class, and we will call this class fraction. There we go. So I've got my new class fraction. What I want to do is use a lot of the values that came in point. So in other words, I want to use the x and the y and some of the settings that went into setting up the point. What I don't want is to print it out as a coordinate. I want to print it out as a fraction, so in fraction notation. So I'll set up a few methods inside fraction to handle that. So the first thing I need to do is say, and this is inheritance, that I am going to extend the point. Now when I do that, the first thing when I create a new fraction is that it actually calls this function here, and it's going to set it to 0, 0. And for those of you who know fractions, you cannot have 0 as a denominator. So we're never ever going to use the basic fraction. I'm always going to have to set a fraction to have values. So I never want to have 0, 0. It doesn't mean 0, it's not defined as a fraction. So I'm going to set a constructor for it, fraction. I'm going to take two values. I'm going to take the integer for the numerator and the integer for the denominator. And all I'm going to do, because I've extended point, I now have access to all of the functions and methods that were in point, because they are all public, so I have access to them. And I'm going to use one of those to set up the numerator and denominator. And also, because it's been extended, what you can't see is that it's got an x and a y sitting here. So we are going to set those values. So because we've got two values, we need to use the set xy, and what I'm going to do is just set xy, numerator and denominator. Job done. So this inherits x and y, which we are going to be using as numerator and denominator. So every time I set up a fraction, I can set the numerator and the denominator. Pretty straightforward. Now, I did say that we had difficulty with the denominator was 0. And I'm going to have to sort of, when I use this set xy here, set a, that can be 0, that's fine. But here when I set the y as 0, I don't want this to happen. And I don't want to put my check in here. So what's going to happen is this is going to call set y, which is here, and really what I want to do is check if this is 0, print out an error message, and if it's not 0, then make the denominator whatever the value is. But if I change it in point, that's going to sort of invalidate what happens to my point. I will never have a point which was 0, 0. I'd never have a y value which was 0. So I don't want to do it in here. So I'm sort of going to override it in my fraction. I'm going to have a function of the same name, or a method of the same name. So public void, because it's not going to return anything, and I'm going to give it exactly the same name and exactly the same number of parameters. Okay, so that's overriding it. So when we create a new fraction, instead of using, well, this one's going to use the points version of set xy, this is not going to use the points version. It's going to override it and use what we have inside here. So now I can do a check. So if the y value is equal to 0, then I can print out a message. I can handle it differently later, perhaps. I'm just going to print it for the time being. Print line, and let's use the divide by 0 error. Divide by 0 error. So if my d is 0, when I use set xy, what's going to happen is it's going to call set xy in point, which we are here. Oop, let's drag down. Which we are here. It's going to take these two parameters a and b. It's going to use set x to the a value, but it's going to use points set x method. But when it comes to the set y function, what it's going to use is the fractions version of set x. So we're sort of overriding it. If it's not 0, what we're going to do is set the y. Now this is strange because we actually want to use this set y now in point, okay, so that we can set the y value to what it is. And because this is sort of fraction is descended from point, point is above it in the hierarchy, we need to call the super. Okay, so we're asking to call the super classes set y. Okay, and if we give it the value that we've passed in, y, that will now call points y. But what we do know is that it's not 0. It will never be 0 because we've handled that in here with a sort of override mechanism. Whew, that was a little bit tasty and difficult to get your head round. If you want to go back through it, one way that you can do it is print out messages to see where things are being passed and which particular method is being called at any one time. I'm not going to do that unless I receive some sort of error which I need to point out to you. So that took a lot of understanding, the fact that we've got our own version of set y, but we call points set y when we're happy that the value we've got is okay. So pretty much done for that. The only other thing that I want to do is use a term from fractions. In point I had something called flip. Okay, I had a method called flip, and I want to do that in fractions as well. Now the fraction version of flip is called reciprocal, so I want to have a fraction term to make sense. So if I have another method, public and this is going to be void. Oops. And I need to give it the name reciprocal. So that's the fraction definition of it. Then all I'm going to do inside here is flip. Okay, so I've got my own version of turning a fraction upside down, but I've called points flip. Last thing to do really with this, so we can see what's happening, is as we did with point, I want to be able to print the fraction out in a fraction sense. So I really need to sort of copy this function here. In fact, let's see if I can copy it all and paste it into fraction. I'll change what I need. So we've got the toString function, but this time I don't need to place it in any brackets. That's fine, and I don't need a comma sign. All I need is a / sign. So obviously we can't have A over B. I've got to have A / B to be my fraction, and that really is setting up my fraction. So that defines a fraction. So that was quite, although difficult to get your head round, it was quite easy to set up, because we extended point. We've done the majority of the programming that we require in point. So that was the point of doing so much work in here. So in the next video we're going to check out our fraction, see what happens to it, and create a library which then operates on fractions and lets us add, subtract, multiply, divide, and so on.